In this video, I'll be starting to solve the 1993 AP Calc AB multiple choice part of the exam. And as usual, I'll give the disclaimer that I'll leave it up to you to determine whether the content that's covered on this exam is the same as the content covered in, I'm assuming you're taking Calc AB, the year that you're taking it, okay? When you're watching this video. So let's begin. Interestingly, this year they allowed a scientific calculator. Most of the problems, you don't need it. There's some that it's helpful to use a calculator, but not needed. Some are, you need a calculator because if you find it in exact form, that's fine, but then the answer, the multiple choice to give is in decimal approximation. So at those times you would need a calculator. Okay, so let's begin. F is x to the 3/2 power. F prime of 4 is what? Let's find f prime. What's f prime? We just use the power rule. That'll be 3 over 2 x to the half power. Okay, and we evaluate this at x is equal to 4. That's 3 over 2. X to the half is the same thing as square root x, so it's square root of 4, which is 3 over 2 times 2, which is 3. Number 1C. Number 2, which of the following represents the area of the shaded region in the figure above? So area is upper curve minus lower curve. Okay, we can integrate in terms of x. They have a y, but f of y dy from c to g. Okay, anyway, let me do it in terms of x. Okay, remember it's upper curve minus lower curve. What's the upper curve? It is just d. It's this horizontal line d. Y is equal to d. Okay, so we can even write that. Y is equal to d. So it's upper curve minus, what's the lower curve? It's f of x. Okay, and limits of integration, we're integrating in terms of x, so it's from a to b. Okay, did we get one of those? 2 is b. Okay, why is it not a? First of all, it's not clear what f of y is. Let's assume that this guy is f of y. Okay, if we integrate in terms of y, it would include this rectangular region, okay, which we don't want that. So this would have to subtract a in the integral, in the integrand. So that's not. So this is why that's not correct. Okay, and then I won't go through the rest. Those should be more self-explanatory. Okay, we have this limit as n goes to infinity, 3n cubed minus 5n over n cubed minus n squared plus 1. Okay, so how do we solve this? Well, if you know the shortcut way, we know that this is a horizontal asymptote. This is asking about n behavior. This is a rational function. The degree of the top is equal to the degree of the bottom. We take the ratio of the leading coefficients, just 3 over 1, which is 3. That's the easy way. Okay, if you don't remember that, you can note the long way, which I did over here. Here's the problem. Okay, we can factor our n cubed on top and n cubed on bottom. Let me zoom in the camera a little bit. Hopefully this is more clear. Maybe, is it focused? I think it's focused. Okay. So I factor our n cubed and n cubed. Okay, so what's left on the top is just 3 minus 5 over n squared. What's left on the bottom is just 1 minus 2 over n plus 1 over n cubed. As n goes to infinity, this guy would go to 0. This guy would go to 0. This guy would go to 0. N cubed and n cubed, it would cancel out to a 1. Okay, so we're left again with 3 divided by 1, which is just 3. That's how we solve that one the longer way. Okay, let me zoom back out. Next, we have this guy. We want to find dy dx. Okay, so let me solve this. We need to implicitly differentiate, so derivative of x cubed is 3x squared. Derivative of this guy, we need the product rule. So first d second plus second d first. Okay, that would be the product rule for that. And then derivative of 2y cubed would be 6y squared dy dx. That's a y. root of 17 is just 0. Okay, so let's solve for dy dx. 3x dy dx plus 6y squared dy dx is equal to minus 3x squared minus 3y. So I move this term and this term to this side. We can factor out a dy dx, so let me just do that. Okay, and then we just solve for dy dx by dividing by this guy. Okay, we probably want to factor a 3 on the top and 3 on the bottom to get it to match one of these. So, and we can even do a, should I do a 3 or a negative 3? Let me just do a 3 first. Okay, so we got this. 3's can cancel, so we get minus x squared minus y squared over x plus 2y squared. Okay, we don't quite get that, but we could factor out a negative 1 on top, so negative x squared plus y squared over x plus 2y squared. So that should be a. Right? Yes. Okay. That's how we do that, implicit differentiation. If the function f is continuous for all real numbers, and if f of x is x squared minus 4 divided by x plus 2 when x is not equal to 2, then f of 2 is equal to what? Well, we know that there's a hole in f at x is 2, so that's why, well, first of all, if just looking at the domain, here you can already tell x cannot equal to 2, but we see that there's a removable discontinuity, or a hole, because you can even factor the top to be x plus 2, x minus 2, right? And actually, we're going to use this to find f of negative 2. We're going to take the limit as x goes to negative 2 of the function, okay? So as it just said, we can factor that. That's what I did over here, okay? And then we see that the x plus 2's can cancel. So we're left with x minus 2 to take the limit of, hopefully this negative is visible, of this guy, okay? And so we can just plug in now, negative 2 minus 2, which is negative 4. Okay, so 5 is there. The area of the region enclosed by the curve, y is 1 over x minus 1. The x-axis in the lines x is 3 and x is 4 is, okay, so you should know how this guy looks, okay? You should know how y equals 1 over x looks. How does that look? It looks something like this, right? This is 1 over x. Hopefully you're able to remember that. This is just shifted over by 1, okay? You can even see that because when it's 1 over x, the vertical asymptote is that x is 0. Now it got shifted to x is 1, so it's shifted to the right, okay? So we only care about what's in this side because we're bounded by x is 3 and x is 4, okay? So this asymptote I said would be where 1 is. So 3 is somewhere here, 4 is somewhere there. So and this is the curve. So we're interested in this area. So area under the curve, that's just the integral. So we integrate from 3 to 4, 1 over x minus 1 dx. This is just the log, so log of x minus 1, evaluate from 3 to 4. So that's just ln 3 minus ln 2. We can combine the two logs, ln of 3 over 2. Okay. Equation of the line tangent to the graph of y is this guy at the point 1, 5 is tangent line. The slope of the tangent line is the derivative. So let's find y prime. Okay, so if this is y, we need to use the quotient rule. Y prime is bottom d top, derivative of 2x plus 3 is just 2, minus top d bottom, derivative of the bottom is just 3, over bottom squared. We don't have to simplify, we just evaluate at x is equal to 1 directly because we want the slope of the tangent line at the point 1, 5, which has x is equal to 1. Okay, so we evaluate x is equal to 1. What do we get? We get 3 minus 2, which is 1, times 2, minus 2 plus 3, which is 5, times 3 over 1 squared. Okay, which we get minus 13, negative 13. Okay, we have the point 1, 5. We have a slope. We can find an equation of the tangent line. Y minus 5 is minus 13, x minus 1. I feel like it's not quite visible on camera for some reason. Okay, so I just solved it in slope-intercept form. So y is equal to negative 13x plus 18. Okay, which we didn't need to get it in slope-intercept form, but this helps me because I can just see it matches B. 7 is B. Okay. Y is tangent x minus cotangent x. dy dx is equal to what? What's the derivative of tangent? That's secant squared. What's the derivative of cotangent? Minus cosecant squared. You should remember these. So there's just secant squared plus cosecant squared. 8 is E. Easy question. If h is the function given by h of x is f of g of x, where f of x is 3x squared minus 1, g of x is absolute value x, then h of x is equal to what? So we want f of g of x, so we're going to plug in g as x inside f. So it'll be 3 absolute value x squared minus 1. We plugged in g as x into f. Okay, so then absolute value squared, so absolute value is going to make it positive. Squared is going to make it positive also. So we can just write it as 3x squared minus 1. So 9, we can write it as E. Okay. If f of x is x minus 1 squared, sine x, then f prime of 0 is, so did I do this beforehand? I did. So here we need product. Well, first d second plus second d first, and then evaluate x is 0. Okay? So here's f. So f prime is first. So we need the chain rule here. So it'll be power rule first 2 times x minus 1 to the first power times derivative of x minus 1, which is 1. It's a first d, I flipped the 2. So first d second would be x minus 1 squared times derivative of sine, which is cosine. That's here. And this one was second d first. Okay? We evaluate it at x is equal to 0. Okay, let me zoom more in. Maybe that's why. Can't see it that well. And let me adjust the focus real quick to see if I can get it better. I apologize for doing this in the middle of the video. I don't think I can get my pencil handwriting better. Okay, sorry about that. If it isn't clear on camera, I'm not sure how it'll look on YouTube. But okay, so we found the derivative. We evaluate at x is equal to 0. This term would go away because sine of 0 is 0. So we're left with cosine 0, which is 1. 1 times 0 minus 1, which is negative 1. Negative 1 squared is just 1. So we're left with 1. Okay? So 10 is D. 11. A solution of a particle moving along the x-axis at a time t is given by a of t is 6t minus 2. If velocity is 25 when t is 3, position is 10 when t is 1, and the position x of t is equal to what? Sorry, I'm going to focus the camera one more time. I feel like that x of t is not in focus. I feel like this is a little better. This looks better now. Okay, sorry about that one more time. Okay. We're given a solution. We want to find position. We got to integrate a solution twice. Okay, so did I do this beforehand? I did. Okay, so if a of t is 6t minus 2, we're going to integrate to get velocity. Okay, so we just use the power rule. It'll be 3t squared minus 2t plus c. Okay, we're given the condition that the velocity at times 3 is 25, so we can use this initial condition to find c. V of 3 is 25, which is equal to 3 times 3 squared, which is 9, so I'm plugging t as 3 here, minus 2 times 3 plus c. Okay, so if you solve it, you should get c is equal to 4. Okay, and then v of t is 3t squared minus 2t plus 4. This is our particular solution. So we got to do it one more time to get, we integrate it one more time to get position. X of t is integral v of t dt. So it's just power rule again. That's t cubed minus t squared plus 4t plus c, right? Yes, okay. And we're given the initial condition x of 1 is 10. So x of 1 is 10, which is equal to, we plug in t as 1 over here. 1 minus 1 plus 4 times 1 plus c. c is equal to 6 if you solve for c. So our final solution is t cubed minus t squared plus 4t plus 6. Okay. F and g are continuous. F of x is greater than or equal to 0 for all real numbers x, which of the following must be true. Okay, if we have a product of two things, can we break up the integral like this? Only if one of them is a constant. Otherwise, this is not true. You can easily find a counterexample, but if you know your properties of integrals, you can only do this if one of them is a constant. Okay, integral of f plus g is the integral of f plus integral of g. That's correct. That's a property of integrals. Remember, area, you can add two areas together, basically. Okay. Now this one, if we have integral of square root of f, is it the same thing as square root of the integral? No, we can't do that either. No property allows for that. So it should be 2 only, so 12 is b. Okay. And again, you can easily find counterexamples for those two. Okay. I'm trying to organize my papers over here. Okay. Fundamental period of 2 cosine 3x is, well, remember, if we have cosine of omega x, the period is, t is 2 pi over omega. So it's just 2 pi over 3 in this problem. 13's A, as simple as that. We have this integral of 3x squared over square root of x cubed plus 1. Here we can do a substitution. U is x cubed plus 1. du is 3x squared dx. So our integral becomes 3x squared dx. That's just du over square root of u. This is just power rule then. It's just 2 square root of u plus c, and then we back substitute u as x cubed plus 1. So 14 is A. For what value of x does the function this guy have a relative max? This should signal first derivative test. Okay, let me see where I did that. Okay, so I did it over here. So this is our f. Let's find the derivative. F prime would be, we need product rule again. First d second plus second d first. So did I do first d second over here? Yeah, first d second derivative. This guy, we need the power rule first. 2 times x minus 3 to the first power times derivative of x minus 3, which is just 1. Okay, so that's this guy plus second d first derivative of x minus 2 is just 1. Okay, so we get this guy, this line here. To make our lives easier, we can factor out x minus 3 from both terms. When we do that, so that's this guy here, we get 2x minus 4, that's here, and then plus, we have one remaining x minus 3 over here. And we can simplify this to 3x minus 7, okay? So we can easily find our critical points now. X is 3 and x is 7 over 3, okay? We do our first derivative test. We plug in some number much less than 7 over 3. Like, you can even plug in 0. This would be negative. This would be negative. 2 negatives make a positive. You plug in some number between this point and this point. You know that 6 over 3 is 2. So this is like 2 point something probably. And this is 3. So you can plug in like 2.9999, something very close to 3. Okay? So if we plug in something very close to 3 but smaller than 3, this guy would be negative, or we should plug in here, this guy would be negative, this guy would be positive, okay, because it's very close to 3, so you can imagine it as even being 9 minus 7 almost, so that's positive. Negative and positive make a negative. Plug in a huge positive number, this will be positive, this will be positive, so the sign is positive, okay? So since the derivative changed from positive to negative, at this point, this would be where the relative max occurs, okay? And that is D. Okay. Slope of the line normal to the graph of this guy at x pi over 4 is what? Okay, so I did this beforehand, but I could fit it in here even. Normal line is perpendicular to the tangent line. Let me even write that down. Okay, so let's find the slope of the tangent line first, and then we just find the negative reciprocal. Okay, so slope of the tangent line, that's derivative. Y prime would be, here we need to use chain rule carefully, so it'd be 2 times derivative ln is 1 over the argument times derivative inside, derivative of secant is secant x tangent x. Okay, this secant and this secant would cancel, so we're left with 2 tangent x. Let's evaluate x is equal to pi over 4. What is that? When x is pi over 4, tangent is 1, right? So it'd just be 2 times 1, which is 2. So this is the slope of the tangent line. We want the normal line. So I just said earlier, we take the negative reciprocal. So it'll be negative half. So that's B. Okay. We have this integral, x squared plus 1 quantity squared dx. We can just expand this out to x to the 4th plus 2x squared plus 1 dx. And this is just simple power rule, right? It's just x to the 5th power over 5 plus 2x cubed over 3 plus x plus c. 17's E. F of x is sine of x over 2. Then there exists a number c in the interval pi over 2 less than x less than 3 pi over 2 that satisfies the conclusion of the mean value theorem. Which of the following could it be? And what's the mean value theorem say? Okay, so this guy has to be differentiable, which it is. Okay, it says that in this interval, since this guy's differentiable in this interval, there exists some point c such that f prime of c is the average value, f of 3 over 2 minus, 3 pi over 2 minus f of pi over 2 over 3 pi over 2 minus pi over 2. The average value, the average change, even, right? Average value, that's the better term. Okay, so sine is x over 2, so f is sine x over 2. So it would be sine of 3 pi over 4, which is root 2 over 2, minus f of pi over 4, which is also root 2 over 2, over, you subtract these two, that would be 2 pi over 2, which is pi. The top is 0, so we get 0. Okay, so we get that the derivative is 0 at that point c. Okay, so let's find where that c is. F prime is, remember f was sine of x over 2, we need a chain rule. It'll be cosine x over 2 times half. We set that equal to what we found up here, equal to 0. Okay, so you got to be careful with your trig here. We know that x, so we can even write it as cosine x over 2 is equal to 0, okay? So x over 2 would have to equal to pi over 2, 3 pi over 2, so on and so forth. Those are just solutions of cosine, right? So x, you just multiply 2 on both sides, is equal to pi. That's the only one that's in the interval they give. So that's D. Okay? This should be, you should recognize this as solving trig equations, if you remember that in pre-calc. Okay? Let f be the function defined by f of x is x cubed for x less than or equal to 0, x for x greater than 0. Which of the following statements about f is true? Is f odd? Well, if it's odd, it's symmetric about the origin, right? And clearly this is not the case because it's x cubed, so it looks something like that, right? When x is less than or equal to 0, and then it looks like this. There's no symmetry at all. Is it continuous at x is equal to 0? Well, what's the limit from the left and limit from the right? From the left, it is 0 cubed, which is 0. Limit from the right, it's just 0. We just plug in 0 there, right? Limit from the left equals limit from the right. So limit as x goes to 0 is 0. What is f of 0? F of 0 is this branch, right? So it would be 0. So it's continuous because it satisfies the definition that limit as x goes to 0 is f of 0. Okay? F has a relative max. Actually, did I? Like this should be x, like that. Okay? Does this have a relative max? For my sketch, I don't see it, right? And then the derivative at this point doesn't even does it exist? It does not exist. So, because of the sharp turn. So, it cannot be a relative max there. Okay? So, not that. F prime is 0, 0. I just said the derivative doesn't exist. There's a sharp turn. When we approach from the left, the slope of the tangent line is close to 0, right? But when we approach from the right, it's always 1, the derivative. So, derivative does not exist. F prime of x is greater than 0 for x not equal to 0. Is that true? Well, the derivative when x is greater than 0 is always 1. The slope of the tangent line is always 1, right? And then you can just visualize the slope of the tangent line is always positive when x is less than or equal to 0 also, or less than 0. Okay? So, this is true. Okay, so one more time for why this is true. Derivative is, or even you can think, is f increasing all the time? When the derivative is positive, f is increasing. F is increasing all the time. Except when x is equal to 0. Okay? So hopefully that helps. And I'll call it a part here. So please like this video if you found it helpful. And please subscribe to look out for the next part.